All right, continuing from where we left off. Last time we created an error response and we created our web application exception mapper so that we could return some JSON data from our REST endpoint. Now I did go ahead and implement some unit tests for both of those. For the error response, I did add JSON serialization and deserialization. So I created an error response object, and then I convert it into JSON to verify that we can serialize it and verify the expected output looks like JSON. And then I do the opposite. I start with the JSON string and then use the Jackson object mapper to read that JSON into an error response object, and then I verify that everything's the same. Now to compare these two error response objects with assert equals, I did need to implement the equals and hash code methods, which I just let IntelliJ generate for me. And since I did that, I went ahead and added the toString as well. So that's it for the error response test. I also added this web application exception mapper test. So basically, given an exception, pass it into the web application exception mapper toResponse method, and then verify that that response looks correct. So everything's looking good there. Now, because I brought in this new object mapper, when I go to build it, I'm now using some additional, you can see them up here, some additional classes which are in some Jackson dependencies that I haven't brought in yet. So I'll go ahead and bring those in. Those are part of the same BOM in the top level POM, the Jackson BOM. Yeah, here it is here. So not only does Jackson annotations come from in there, but also Jackson data bind and Jackson core are defined there as well. So really all we have to do is copy these, this Jackson annotations, and add data bind in one and core in the other. I guess I'll sort these. And now we should be able to build. All right, everything's looking good. All right, now we're all pushed up. So the next thing I want to start is the database code. We haven't talked at all about what kind of API we're going to provide. So just since we're mostly focused on the process of starting from scratch and building out support for an API, we'll do something simple. We'll create an API for managing to-do lists and the items on that to-do list, or on those to-do lists. So let's go ahead and create a database to hold that information. We'll need a database module in our Maven project. So let's go ahead and do a new directory. We'll do tutorial API DB, and we'll want a source main Java in it, and we'll want a com tutorial API DB package, and we'll basically do the same thing but for tests. Source test Java com tutorial API DB. We'll need a POM, so let's go ahead and copy paste our model POM. We'll swap this out for DB. We are going to use JUnit for unit testing this, so I'll leave that dependency in here. And in our top level POM, let's add this as a new module. And go ahead and Maven reload so that we can verify that all this is looking good. Let's also add a new resource directory, and we'll go ahead and add a new test resource directory as well. All right, so we're going to need some dependencies. For database, we'll use Sqlite. At least initially, Sqlite's good enough to get us, to a point where we have enough data to use Amazon, AWS, RDS, their relational database system. So we'll just start with Sqlite and treat it like a Jdbc database, just like we would Postgres or MySQL or any other, except we'll use an in-memory version of it for our tests, and then we'll use a file system version once we deploy to a production environment. So Sqlite, so Sqlite homepage, you can read about it. It's small, fast database. It's usually used with a file as it's where the data is stored. So you can read about it, Google it. We're going to use the Java Jdbc library to talk to it. Jdbc is Java's database connectivity library. And let's go ahead and find it. Yeah, Sqlite Jdbc. So let's copy the latest one. We'll put that in our top level POM. Org.serial, or whatever, however you pronounce that. I'll also copy it up into our database module. We're also going to need a database connection pooling library. I like to use Hikari. From com.zaxer. It's pretty good connection pooling. So let's come in here and get this. We'll add it in here. Alright, a few comments to describe why we're using those dependencies. And another dependency I like with databases is Flyway. So Flyway provides the ability to do database migrations. So basically, right, we'll start out with an initial database schema, and if we change it over time, then we can add a new Flyway SQL script to migrate our current database to our new database. So let's go ahead and bring that dependency in as well. So org.flyway. Alright, let's go ahead and Maven reload here so that we can access these dependencies. Alright, so let's go ahead and start implementing this. At the top level, let's create an interface called Service Factory. We're going to probably end up with kind of a lot of interfaces mixed in here. And we'll create a new service package. And we'll define a new Java interface in here for our to-do list service. We're actually going to want a to-do list model object. So let's open up our model package as well. Now these are kind of user classes. Maybe we should separate those into their own package. In fact, let's go ahead and do that. All right, so for our to-do list, we'll have an ID for it, and then we'll give each list a name, I guess. Let's create some getters and setters for these. I like changing these voids to the object type, so that way I can use fluent method chaining when creating model objects. So that way I don't have to do builder things, right? I don't have to use the builder pattern. I can treat my object itself as a builder and you know, just chain these set methods together to set a bunch of things kind of all at the same time. Let's add an equals and hash code and a toString. So of course Java, a lot of boilerplate. We just let IntelliJ generate that stuff for us. We'll also need an entry into a to-do list or an item in the to-do list. I guess we'll call them to-do items. These will have an ID as well. We'll have I guess the task that needs performed and a Boolean indicating whether that task is done or not. And we'll default it to false. Same thing here, getters and setters. And equals and hash code. And toString. Alright, so these look good. I'll close this and this. So our service factory will return a new to-do list service factory, our service. And we'll also create a to-do item service. All right, so let's populate these interfaces. Let's let that one pick up that import. So for our to-do list, we'll do so we can't actually see the to-do list object because it's in model. Let's go ahead and import or add model as a dependency. And since we've created our tutorial API DB module, let's come up here and add it to our top level POM. So that way we can, or no, let me update this. So we can add database code into our server at some point without having to specify a version because we've already defined it in dependency management. Okay, let's update this. Now, so all these methods are going to take a Rapid API principal, which is the user who's making the API call through Rapid API. So that way, right, we only want to return the to-do list for this particular user. We'll also do get all. We can also do, I guess, something like create. And update. And delete. And let's do truncate as well to delete the whole, everything in the database. We'll also we'll add similar methods into our to-do item service. Oops. All right, so for to-do items, each item is going to be part of a list. So let's add support for lists in here. So if I'm going to fetch a specific to-do item, I'll fetch it within a particular list ID and for a particular user. If I'm going to get all, I could get all items from a specific list. If I'm going to create or update an item, I want to create it or update it for a particular list. And same with delete. And then truncate will just delete everything. Okay, so these are looking pretty good so far. Let's go ahead and create a new package for Sqlite. So we could have multiple different types of these services. For example, we could have a Sqlite implementation, a Postgres implementation, an Amazon RDS implementation. We could have an in-memory implementation. So all the implementations would be in their own packages. For now, I'll just create a Sqlite implementation. And then our service factory implementation would determine which service implementations would be fetched. That all sounds confusing, but it'll probably make sense once I make it a little bit further. So let's create a new Sqlite to-do list service. This implements the to-do list service. Let's implement all these methods. So we've got some default implementations for now, and we'll come back and fill those in a minute. Let's copy this. Actually, let's not copy it. Let's just start a new one. New Java class. Sqlite to-do item service. All right, so now we've got some empty services. These services are going to need a data source to be able to talk to the database. So data source. So we'll create our to-do item service and we'll pass in that data source. And then we'll use that data source down in here in a little bit. Let me copy that and we'll come over here. Do the same thing here. Okay, so now we've got some empty implementations. Let's go ahead and create a new, I guess a Sqlite. Well, I'll call it default service factory. Actually, let me do this. So we'll create some private final to-do list service, an item service, and then we'll create those. So to-do list service equals new Sqlite to-do service. Yeah, so we could pass configuration information in here, a config object or an enumeration that tells us what type. And then depending on that type, we could either create a Sqlite implementation or a Postgres implementation or whatever. And then this service will return those implementations that are created. All right, so this is the basic layout. Up in our server and REST stuff, we'll get access to a service factory, and then we can call get to-do list service if we need to do to-do list things, or item service if we're going to do item things. And then those would reach down into the actual Sqlite implementations, which would do basically pull a connection, a database connection out of the data source, and then perform actions on that data source. And we'll get to that in a minute, that actual implementation start. Let's go ahead and start our database testing code, because we're going to want to test this pretty thoroughly to make sure our database implementation does exactly what we want kind of throughout. In fact, I'll go ahead and pause here and we'll pick up on the database testing in the next one. All right, thanks a lot, bye.